Good evening, sir.
Good evening, sir.
Good evening. Okay, so we'll continue with our discussion from the last class, and we'll start off with the ideas of congruences. So the first thing is the definition. So if a, b, and n are integers, we say that a is congruent to b modulo n, and we write it as a congruent to b mod n if n divides a minus b. So basically the basic idea is that a congruent to b, we write mod n. That implies n divides a minus b. What this means is that both a and b, leave the same remainder when divided by n. Only if both of them will leave the same remainder when divided by n can we have that n will divide the difference, right? Basically, a, if you divide by n, you can write it as nq1 plus r1. And b, if you divide by n, you can write it as nq2 plus r2. If r1 is equal to r2, that implies that a minus b will be equal to n times q1 minus q2. Correct? And that
Correct.
implies that n divides a minus b. Is it clear what I'm saying right now?
Yes, sir.
Yes, sir.
So all of these things mean the same thing. When you say a and b are congruent modulo n, it means n divides the difference of the two numbers. It also means that both a and b leave the same remainder when divided by n. So that is the basic definition. And whenever you divide a number, okay, so there is an additional definition that you need to know, which is part B, which says the definition of a residue class. The residue class of a modulo n, is the set of all integers congruent to a mod n. So what does this mean? So let's say let's say n is equal to 3. When you divide an integer a by 3, the remainder a mod 3 could be 0, could be 1, could be 2, right? So basically, now we are going to say that the remainder could be any of these three values. Now we are going to say that these three values define their own residue classes. Residue classes, which are what? Which are basically set of all numbers congruent to 0 mod n. The residue class here is set of all numbers
Acha,
congruent to
in form of 3k or 3k plus 1 like this, right?
so all numbers congruent to 1 mod n will be all numbers that leave remainder 1 when divided by n, right? In this case, n is 3. So here this residue class is set of all numbers that are congruent to 2 mod n. So if you think about it, all of these sets are infinite sets. This set, the set of 0 mod n residue class, is all the numbers like this: 0, 3, 6, -3, -6. This is an infinite set of multiples of 3, right? This is an infinite
Yes,
set
sir.
of 1, 4. Actually, you can go back also, -2 and stuff. 1, 4, 7, 10, and so on. Similarly, this is an infinite set of -1, 2, 5, and so on. So these are all your residue classes. Residue class is a set of numbers which are congruent to, let's say, A mod n or B mod n. Every value of A defines a separate residue class. Is it clear what I'm saying?
Yes, sir.
Note
Yes,
that
sir.
the elements of any residue class. When I say that, I mean elements of the set here will be in an AP, will be in an arithmetic sequence. Obviously, the common difference will be the n, that is the modulo n, right? Here, the residue class has modulo 3, so therefore, all the APs here will be common difference 3. If you are dividing by a different integer, then the AP would be common difference n. Correct?
Yes, sir.
Okay. Now we will look at some basic properties of the congruences. Basic properties of the congruence relation. What is the congruence relation? When I say that, what I mean is A is congruent to B mod n implies n divides A minus B, or implies A and B belong to the same residue class modulo n. I hope these definitions are obvious by now. So now that we know this congruence relation, now we will define some basic properties. First property is that the relation is reflexive. This is the reflexivity property. By reflexivity means with itself the relation is true, because clearly n divides 0, because any integer divides 0, and 0 is A minus A, right? Correct?
Yes, sir.
Then we have symmetry property also. If A is congruent to B mod n, that implies B is congruent to A mod n. There is no issue with symmetry, because n divides both A minus B and B minus A. There is no issue there. Then there is transitivity. A is congruent to B mod n and B is congruent to C mod n implies A is congruent to C mod n. This is the transitive property. The proof of these are super easy, so I'm not saying the proof. I hope everyone realizes that the proofs are obvious.
Yes, sir.
Okay. The fourth property is if A is congruent to C mod n and B is congruent to D mod n, then we can say the following three things: A plus B is congruent to C plus D mod n. We can also say A minus B is congruent to C minus D mod n. And we can also say AB is congruent to CD mod n. we cannot say in a guaranteed way the division rule. We can say it for addition, subtraction, and multiplication. As long as you have the same moduli, it is guaranteed that A and C are congruent and B and D are congruent, imply that A plus B is congruent to C plus D. Similarly for subtraction and multiplication.
Yes, sir.
Again, the proof of this part can be done. There is no issue with the proof. You can
Yes,
prove
sir.
that A plus B minus C plus D and will divide that. You can try it out
Yes, sir.
yourself also. All of these three can be proved by the same method. Follow the definition to prove it. Right?
Yes, sir.
Okay. Notice that division has not been mentioned because division is not necessarily true. You
Yes, sir.
cannot guarantee that A by B is congruent to C by D.
Hmm.
So that is not there. So remember that division is not true necessarily. Sometimes it might happen, but it's not guaranteed. Okay. Then fifth property is if A is congruent to B mod n, then from here we can say that A times C will be congruent to B times C mod n. That is again obvious from the definition. No, I have made a mistake. A times C will be congruent to B times C mod NC. So let's try to prove this one. Again, not very difficult. From here, what we know is n divides A minus B, right? So A minus B is equal to K times n, where K is some integer, right? Correct?
Yes,
Yes.
sir.
Now here, we want to prove this is true. So we want to show that AC minus BC is divisible by NC. So we need to show that NC divides this, right? Actually, it is obvious.
We can multiply C on
Yes.
both sides of the equation here.
So here only we can just multiply by a constant C and we get that A and C, right? So that immediately proves this, so it is obvious, right? So even though the property is obvious, don't think that it will not be used or it is a useless property. It will be used. See, we are making a bigger number here and everywhere we are putting that, right?
Hmm.
Now notice one thing, the converse of this property, if AC is congruent to BC mod NC, right? And C is not equal to 0, right? Then you can cancel, correct?
Yes.
Yes, sir.
Do you realize that the converse will work only if you can divide by 0 from here, divide by C from here, right? If
Hmm.
division by C is allowed, then you can go from here to here, right? So C should not be equal to 0 and basically the converse is also true and this is going to be used more often because many times you want to cancel some common factor if possible, as long as that factor is
Hmm.
not 0, right?
Yes, sir.
And finally, the last property that we will say here is,
Sir, it is like division of that one, no?
yes,
Division.
if you have this condition already, then we already know AC minus BC is equal to K times NC.
Yeah,
If
so we
you
can cancel out the N by
you can
taking.
cancel out the C if C is not equal to 0. And you will say A minus B is Kn. So therefore, this is true now, right?
Yes, sir.
So it is the division of, it is the opposite of it. And obviously here we did it by multiplication. So here we are doing it by division. Then the next property is important. If AC is congruent to BC mod N, it is not mod NC here. And C is relatively prime relatively prime to n, then A is congruent to B mod n. This is a very important property. So
Yes.
the normal easy property was 6, where you had AC, BC, mod NC, where you can cancel C everywhere. And from there you can say that obviously this is true. But this is not at all obvious.
That this can be done easily, like if n divides AC
I know
minus
it
Yes,
can be
sir.
done easily,
We
but
can
it
take
is not an
uh,
obvious property. I know that the proof is easy, but the property is not obvious like 6 was obvious.
hmm,
Do you
Yes, sir.
understand what I'm saying?
yes, sir.
The condition is not obvious. It's a very important property because it will be used many times.
Hmm,
It can be done easily is not the point. Pay attention to what is different in the condition and what is the key condition.
yes, sir.
If C is relatively prime to n, then we can cancel C off without worrying about having to cancel it from the modulo.
Hmm,
Here, you needed to cancel it from everywhere. That's why this is not so useful. Because in problems, you will not be changing the modulo n so frequently. Do you understand what I'm saying?
yes, sir.
The numbers can be different, but you will be using the same mod 3 or mod 5, trying to use the same mod, right?
Hmm,
So this property 6 is not very important because here everything changes. This also changes, this also changes, this also changes, right? But
yes,
this
sir.
property 7 is super important because we are saying that AC and BC are congruent modulo n. That can mean that A and B are congruent modulo n, which is not always true, but it will be true if C is relatively prime to n. Does everyone know what is relatively prime?
Yes, sir.
Yes,
GCD
sir.
1.
So C and n GCD is equal to 1. The proof of this is easy because we already know that meaning of this. So we know n divides AC minus BC. So that means n divides C times A minus B. Now, if n divides C times A minus B, we know that C and n are relatively prime to each other, right? If
Yes.
C and n are relatively prime to each other, then they don't have any common factor, right?
Yes, sir. Then n should be divisible by a minus b.
N should divide A minus B only. It cannot have anything with C, right? So from here, because C and N are co-prime, we can say N divides A minus B is obvious. And therefore, we are saying this. So remember the properties. It may seem obvious right now, but it will definitely be tricky when you do questions. So keep these in mind. Then we will see some consequences of the above properties. There are some more that we can generalize. So for example, if integers k is greater than equal to 1 and you have a1, a2, ak and b1, b2, bk, and you also have a, b, and n. These are all integers. The only condition is that k is greater than equal to 1. Now we are looking at some generalizations. So we are saying if ai is congruent to bi mod n for every I from 1 to k, then what is the generalization? Basically, earlier we said that a plus b was congruent to c plus d, right? Now we are saying that all of the AIs are congruent to all of the BIs, mod n, right? So we'll be able to now say that the sum of all of them is also congruent to the sum of the B's, mod n. So basically, it's an extension of the earlier property which was valid for two terms, right?
Yes, sir.
Yes, sir.
So then the second one is similarly the product of all of them will also be congruent to the product of all of them. Mod n. Correct?
Yes, sir.
All of
Subtract.
these statements can be proved by what method? Induction.
Hmm.
You should take the base case as 2
Two.
and after that do the n case you can assume and after that prove the n plus 1 case. Right?
Yes, sir.
Yes.
1 second, just hold on. Right. So all of the proofs of this can be done by induction. Right now, I'm not doing it because you can try it out yourself. It's not very difficult. Then the third one is if A is congruent to B mod n, then we can say that A power k is congruent to B power k mod n. Obviously, this is similar to this. You just take k times A, right? And k times B.
Yes, sir.
So it is just applying 2 to equal terms A, right?
Yes, sir.
Okay. Then fourth one is slightly more interesting. If f is a polynomial with integer coefficients, and A is congruent to B mod n, then f of A will be congruent to f of B mod n. Think about it. F is a polynomial with integer coefficients. Usually polynomials कैसे होते हैं? ax square plus bx plus c, for example. Right?
Yes,
Yes,
sir.
sir.
Here the thing that he has said is a, b, c are integers. Or let's keep the integers as p, q, r because a and b and all are already there. So our polynomial f of x is px square plus qx plus r. And we know that a is congruent to b mod n. Right? If you look at f of a, what is that? It is pa square plus qa plus r, right? And
Yes.
f of
Yes,
b is
sir.
what? pb square plus qb plus r, right?
Yes, sir.
Automatically from the previous properties, we know that a square is congruent to b square, right?
Yes, sir.
तो ये पार्ट तो कॉन्ग्रुएंट ही है दोनों का.
Similarly, A congruent to B.
तो ये पार्ट भी कॉन्ग्रुएंट है, right?
Yes, sir.
We already know that
वो
if
तो
a and b are congruent, then pa will be congruent to pb, right? We can
Yes, sir.
multiply by a
yes,
constant.
sir.
That is not going to change anything, right? Similarly, if a square and b square are congruent, then pa square will be congruent to pb square, right?
Yes,
So it should be obvious to everyone why for a polynomial with integer coefficients, if a and b are congruent modulo n, then fa and fb are also congruent modulo n. Is it clear?
yes, sir.
Yes, sir.
सबको समझ में आ रहा है ना?
Yes, sir.
Okay. Then two final points of theory before we discuss some questions. So one is let n be a positive integer. First point is two residue classes modulo n either coincide or they are disjoint. So first of all, remember what we mean by residue classes. Residue classes are sets of numbers with a same remainder, right?
Divided by n.
When you divide by n, sets of numbers with same remainder divided by n. When divided by n. And each set is an infinite set, which is an AP, right? Each of these residue classes will be a separate AP, right? We
Yes.
saw examples of that when we did residue classes modulo 3, right?
Yes, sir.
So what this statement is saying is, if you take two of the residue classes, either they will be coinciding, either they are the same, or they will be completely disjoint. You cannot have a number that exists in multiple residue classes. There is no intersection between two residue classes, right?
Yes, sir.
Is it obvious what I'm saying?
Hmm.
Yes, sir.
Yes.
There will be no intersection between two separate residue classes. If there is any element that exists in two separate residue classes, what it means is that those two classes are the same residue class. They will completely coincide, right?
मतलब एक भी
Yes.
हुआ तो like the whole remainder thing is like coinciding.
Obviously. These are separate APs, right? If any element is common, it's the whole thing is common then.
Got it. Cause the n is same, that's why.
The common difference is same and you are dividing by the same thing. So you cannot have any common elements between two different residue classes.
Got it.
The second thing is there are precisely n residue classes, modulo n classes, modulo n, because the remainders can be 0, 1, 2 till n minus 1.
Yes, sir.
So there will be n residue classes, and the numbers in them will be of the form r plus n times any integer z, and r can take values of 0, 1, 2 till n minus 1. Right?
Yes, sir.
Yes.
Z can represent any integer, and n is the common difference basically, right? R can be the particular residue class. So you can have a residue class nz, you can have one nz plus 1, you can have one nz plus 2, and the final residue class will be nz plus n minus 1. Right?
Yes, sir.
Is everyone understanding what I'm saying?
Yes, sir.
Can I rejoin?
You can do whatever you want to. Okay. Fine. So that's the basic theory. Now we'll discuss some questions, and then once we have tried out these questions, after that we'll continue with possibly new theory in the next class. So try out these questions. Let x, y, z be integers. Prove that if x plus 4y plus 5z is divisible by 37, then so is 8x minus 5y plus 3z. Question 2. Let x and y be integers such that 4x plus 3y is divisible by 7. Prove that 5x plus 2y is also divisible by 7. Question 3 is Find the last two digits of one is 7 power 6 power 5 and 2 is 7 power 7 power 7 power 7. Question 4 is let A and B be positive integers such that 7 divides A square plus B square. Prove that 7 divides A and 7 divides B. Try out these 4 questions. You have 15-20 minutes. If you have done one question, then move on to the next one. We will be doing many more questions. So these are just the starting point. So try these out. I'll be back in 5 minutes. Just try them. Anybody has gotten first one?
Sir, done fourth and third one.
First one.
So मैं नीचे से start कर रहा था.
सर ऐसा नहीं कह सकते एक्स एक्स प्लस 4y प्लस 5z इज डिविजिबल बाय 37, तो x will be also divisible by 37, 4y and 5z also, तो
No,
वहां से y and z also divisible by
No,
37.
ये नहीं बोल सकते ना.
नहीं
ये
बोल
नहीं बोल
सकते
सकते
वैसे.
क्योंकि 6 divides 7 + 5, लेकिन 6 doesn't
अगर
divide
x प्लस 4y प्लस 5z डिविजिबल बाय 37 तो इसका मतलब थोड़ी है कि कोई छोटा सा पार्ट उसका भी डिविजिबल बाय 37.
भाई.
कोई तीन नंबर्स
सॉरी
को
सर.
ऐड करके 37 आ रहा है तो इसका मतलब थोड़ी है कि छोटे छोटे नंबर भी डिविजिबल बाय 37.
ओ, हाँ, सॉरी.
When you are saying x plus 4y plus 5z is divisible by 37, what you are really saying is x plus 4y plus 5z is congruent to what mod 37, right?
Yes, sir.
By definition of congruence, this statement should make sense to everyone, correct?
Yes, sir.
So now you can say what are the properties of congruence we know. If A is congruent to B mod 30 mod n, we can say A minus C is congruent to B minus C mod n, right? दोनों साइड से सेम नंबर सब्ट्रैक्ट कर सकते हैं, राइट?
Yes, sir.
यस.
Yes, sir.
So we can say here we can subtract 4y plus 5z from both the sides and say x is congruent to 0 minus so minus of 4y plus 5z mod 37, right?
Yes, sir.
That's the same thing as saying that x plus 4y plus 5z is congruent to 0. So now that we have this, we can now put this x. Since x is congruent to this, we can replace that here. So we'll get 8 times. If you're looking at this number mod 37, we can say 8 times minus 4y plus minus 4y minus 5z minus 5y plus 3z, right? Because we know that x is congruent to this, we have replaced x with that. And we are looking at this mod 37, right? Are you understanding what I'm saying?
यस
Yes, sir.
So
Sir,
now,
can you repeat once more?
सर, डन.
we are saying that if x is congruent to minus 4y minus 5z mod 37, when you look at this number, what do you have to prove? We have to prove that 37 divides this.
हो गया क्वेश्चन.
So technically what we have to show is that this is also 0 mod 37, right?
Yes, sir.
So I will replace x with the congruent thing. I will say instead of x, I will put it as minus 4y minus 5z. 8 into minus 4y minus 5z minus 5y plus 3z. You are getting that is equal to minus 32y minus 5y. So minus 37y. And minus 40z plus 3z. So minus 37z. You are getting that is minus 37 times y plus z, right?
Yes, sir.
That is clearly divisible by 37, right?
Yes.
So that is 0 mod 37 clearly.
Yes.
So the whole thing is 0 mod 37, which means that this is congruent to, this is also divisible by 37. Is it clear?
Yes, sir.
Second one, you can do in a similar way. We know that 4x plus 3y is congruent to 0 mod 7. Okay. So we have to check what happens to 5x plus 2y. We have to find out what is it mod 7. Okay. So from here we can say that if this is congruent to 0 mod 7, if you double it, you can say 8x plus 6y will also be congruent to 0 mod 7, right? By multiplying by 2 on both sides of the congruence. And clearly, this can be written as 7x plus x plus 6y. And 7x is 0 mod 7, right?
Therefore, x plus 6y is also 0 mod 7.
So because 8x plus 6y is 0 mod 7, this is 0 mod 7 now, right? So we are getting basically x is congruent to minus 6y.
Minus 6y mod 7 हो गया.
Once we got x is congruent to minus 6y mod 7, we put it here, right? So we'll say minus
Minus
30y plus 2y. So it is minus
minus
28y.
28y. Of course, 0 mod 7.
So
Hence
we have
proved.
proved that this thing is also 0 mod 7. We are using all the properties of congruence that we have seen so far. We are just multiplying by something, splitting it out. Then we are saying, okay, 7x is 0 mod 7, so this much is 0 mod 7. Then and then we are putting x is equal to minus 6y into the other one.
Yes, sir.
Okay. Now let's look at the third one. So क्या आंसर आया थर्ड वन को तुम्हारा?
सर मेरा पहले का 49 आ रहा है.
पहले का 7 par 6 par 5 last two digits. That's wrong. दूसरे का
सर दूसरे
क्या
का
आंसर?
01 आ रहा है.
नहीं,
अच्छा,
फिर से देखो.
ठीक है सर, एक मिनट देख रहा हूँ. पहला वाला सही है.
नहीं,
ठीक.
03.
पहला वाला 7 par 6 par 5. नहीं,
नहीं, दूसरे का.
दूसरे का भी नहीं है. when you need the last two digits, what are you actually trying to find?
Remainder when divided by 100.
We need what? This mod 100. Correct?
हम्म,
Yes, sir.
तो फिर अब सोचो कैसे करोगे इसको.
सर 909.
इतना सारा आंसर्स नहीं देना है, वो भी गलत है. एक एक करके सारे टू डिजिट नंबर्स तुम लोग बताओगे.
नहीं 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 ऐसा नहीं सर. और two.
First of all, you should start by looking at some basic powers of 7.
पर वही देख रहा हूँ.
हम्म, 7 4 से स्टार्ट करना, मतलब
4
मैंने किया था.
7 to the
7
power
power
4.
4 mod 100 is how much?
One mod.
4
हम्म,
37 minus
Mm.
5
So that will be useful for us because 7 power 4 is coming as 1 mod 100. 1 mod
Yes, sir.
100 is a nice number because whenever you raise it to power k, it remains as 1 only. Right?
Yes, sir.
So because we know that a mod 100 is equal to b mod 100, we can say 7 power 4 power anything k mod 100 will still be 1 mod 100, right?
Yes, sir.
Because this will also be 1 power k is 1 only. So now that will be a powerful way to reduce the powers, right? So this is what? This is 7 power 4k,
49 की मदद.
right? Saurav is saying you should realize that 6 power 5 is of the form of 4k.
4K, yeah.
Why? Because it has obviously 2 power 10. 6 power 5 is clearly having 2 power 10.
Or then.
So that is divisible by 4 definitely. So 6 power 5 is congruent to 0 mod 4, right?
Yes, sir.
So यहाँ पे 7 power 4k जब भी होता है mod 100, तो what is this?
1.
So what we know immediately, since 6 power 5 is of the form of 4k, what is the remainder?
1.
So answer is last two digits are 0 1 here. Is it clear to everyone why?
Yes, sir.
It is not very hard. It is obvious only actually. You had to focus on 7 power 4 and realize what is it mod 100. Now find the second one.
Sir, 07.
No. You have to use the fact that 7 power 4k is congruent to 1 mod 100. Second one is 43. Arjit is correct. The remainder here is 43. 7 power 4k is 1 mod 100, and that implies that 7 power 4k plus 1 कितना होगा? 7
7.
mod 100.
7 more.
7 power 4k plus 2 कितना होगा?
49 mod.
49 mod 100.
Hmm.
And similarly 7 power 4k plus 3,
43 mod 100.
43 mod 100. 4k plus 4 पे जाने की जरूरत नहीं है, क्योंकि 4k से जब 4 से डिवाइड करेंगे तो इतना ही रिमाइंडर आ सकता है,
इतना ही
0 1
होगा।
2 3,
हाँ।
right? So there are only
हम्म
4 options, 1 7 49 43, right?
हम्म
So we have to figure out कि 7 power 7 जो पावर है 7 का यहाँ पे, is it of the form 4k 4k plus 1 4k plus 2 or 4k plus 3, right?
4k plus 3.
ये फिगर आउट करना है. So now how do we figure this out? 7 power 7 किस टाइप का नंबर है? So for that, let's look at 7 itself. Modulo 4. 7 is what? 3
mod
mod
4.
4. We
So
can
7 power
do
7
a
power
little
4.
better.
हाँ.
No, we'll not use 3. 3 is a bad number. We can say 3 के जगह पे we can say it is minus 1 mod 4.
हम्म
3 करोगे तो फिर उसके चक्कर में पड़ जाओगे, 3 के पावर्स के चक्कर में.
हाँ हाँ.
We'll say 7 is congruent to minus 1 mod 4, right?
And the power is also odd.
So now we can raise it to powers, right? From
हम्म
here, we can raise this to the power 7 power 7.
हम्म
So that should be same as minus 1 to the power 7 mod 4, right?
हम्म
Now, if you look at the number 7 power 7, obviously that's an odd number, right?
हम्म हम्म.
So this thing is going to be negative 1, right?
Which is also 3 mod 4.
Which is also 3 mod 4. So we know 7 power 7 is 4k
4.
plus 3k form mein.
Which is leave
Which
remainder
means the
43.
remainder will be 43 then.
हम्म
There is a step-by-step approach. It is not blind stuff. It's not like कुछ भी कर रहे हैं, right?
हम्म
We are thinking of the powers of 7. We have isolated कि 7 power 4 पे 1 mod 100 आ रहा था. So then we started looking at 4k pattern में 4k plus 1, 4k plus 2, 4k plus 3. We have only 4 options. So then we have to focus on our power. And if you focus on your power, not blindly again, we looked at 7 mod 4, it is 3 mod 4. We cannot raise this to the power of k because 3 power k will again become annoying.
हम्म
So what we write 3 instead, we write it as minus 1 mod 4. It's the same thing, correct?
हम्म
Because we can subtract 4 or multiples of 4 from anything when you do mod 4, right? Is it obvious that 7 is congruent to minus 1 mod 4?
Yes, sir.
Yes, sir.
So after that, it is raising it to the power k and
Power
minus 1
7
power
person.
k.
हाँ.
It is obvious why it is minus 1 mod 4 and 4k plus 3 and remainder is 43.
हम्म
Okay. Last problem. A and B are positive integers such that 7 divides a square plus b square. You have to prove that 7 divides A and 7 divides B.
हम्म तो ये हो गया.
Yes, sir.
सर मैं तो वैसे कर लिया कि like if x divides a then x divides b then x divides a square plus b square. तो उल्टा ले गया. या हम मैंने इसको भी 7 divides a square plus b square को मैनिपुलेट कर लिया.
I don't know what you're just saying. If you say things like this, nobody can understand what you're saying.
सॉरी सर, इंग्लिश नहीं आती सर.
इंग्लिश में मैंने बोला है कि बताओ, हिंदी में भी तो कम से कम ढंग से बताओ. इंग्लिश नहीं आती मैं तो प्रूफ कैसे लिखोगे एग्जाम में? यू हैव टू से लॉजिकल स्टेप्स इन अ सीक्वेंस, यू कैन नॉट से इसको उल्टा कर लिया, इसको ऐसे ऐसे कर लिया, हो गया फिर। अरे स्टेप बाय स्टेप में सही से बताओ, हिंदी में बताओ या इंग्लिश में बताओ, दैट इज नॉट इम्पोर्टेंट। क्या किया बताओ।
Sir, can I say?
ओके,
Sir, so all numbers are 1, 0, 1, 2, 4 mod 7 squared. So if we have a square is equal to 0 mod
वन
mod
सेकेंड
7,
वन सेकेंड, इतना हड़बड़ी नहीं है, धीरे धीरे बताओ। क्या ऑल नंबर्स क्या बोल रहे हो?
all numbers are 0, 1, 2, 4 squared mod 7.
ठीक से समझ में नहीं आ रहा क्या बोल रहे हो। तुम क्या बोल रहे हो,
Sir, like,
स्क्वायर नंबर्स?
yes, sir.
आई स्टिल डोंट अंडरस्टैंड व्हाट यू आर सेइंग राइट नाउ, टेल मी
Sir,
प्रॉपर्ली।
sir, I mean, like, if A is like 0 to 6
हम्म
mod 7, then
हम्म
A square would have 0,
हम्म
1, 2, 4 as remainder.
राइट, दैट इज करेक्ट। सो इफ यू आर लुकिंग एट ए, ए के कितने टाइप के नंबर हो सकते हैं? इतने सारे,
Yes,
0 1 2 3 4 5 6। देन इफ
yes,
यू डू ए स्क्वायर और मॉड 7 में देखोगे तो इसका तो जीरो ही होगा, इसका 1 होगा, इसका 4 होगा, इसका
yes,
9 विल बिकम 2, राइट?
yes,
इसका 16 विल बिकम मॉड 7 2 ही है, राइट?
yes,
और 5 का 25 विल बी 4, एंड
mm,
6 का 36 विल बी 1। इज एवरीवन
yes,
रियलाइजिंग व्हाट इज बीइंग सेड? सबको
हम्म,
समझ में आ रहा है बाकी लोगों को?
यस सर।
अगर ए के कितने सारे रेजिड्यू क्लासेस थे? देयर वर 7 रेजिड्यू क्लासेस, राइट? So A can be any number of this form, but when you do square of it, if you do modulo 7, it is not, all of them are not going to work. Only these will work, right?
यस सर।
सबके स्क्वायर निकाल लो और उसका मॉड 7 निकाल लो तो तुमको बस 0 1 4 2 ही आएगा। देन
yes.
व्हाट इज द नेक्स्ट स्टेप?
Sir, if A square is 0 mod 7, then B square would have to be 6 mod 7.
Right, so you can make a table, right? Correct.
Yes,
And
sir.
if A square is 0, B square will have to be 6 mod 7, but that is not possible, right?
Yes.
6 is not possible, no? Mod
Sir, is
7.
7 mod 7.
Wow, 7, which is 0 mod 7 basically, right?
Yes,
So what you are getting is, if A square is 0 mod 7, B square has to be 0 mod 7, right?
yes,
If A square is 1 mod 7, B square has to be 6, which is not possible, right?
yes,
1 and 6 doesn't work. क्यों नहीं काम कर रहे हैं पता है सबको?
yes, sir.
क्योंकि
तुम्हारे
सिक्स
अलावा।
रेसिड्यू क्लास नहीं हो सकता ना, अभी
क्योंकि
हमने
ए,
देखा।
क्योंकि स्क्वायर का मॉड 7 6 हो ही नहीं सकता है, राइट?
हाँ, यस सर।
तो ये पॉसिबल ही नहीं है। फिर 4, अगर ए स्क्वायर को 4 ले लोगे तो
तो
बी
3 हो
स्क्वायर,
जाएगा वो।
वो भी पॉसिबल नहीं है।
हाँ, और 2 और 5 हो जाएगा, वो भी पॉसिबल नहीं है। तो बस ए एंड बी आर बोथ डिविजिबल बाय 7।
We are getting a square should be 0 mod 7
एंड
and
बी
b
स्क्वायर
square
शुड
should be
बी
0 mod 7. None of the other
टू।
possibilities will work.
हाँ, 7 डिवाइड्स ए एंड 7 डिवाइड्स बी।
A square और 0 तभी आ सकता है which when a is 0 mod 7 and b is 0 mod 7. Is everyone understanding what we have done?
यस सर।
This is a very important idea. This is what is called, this what we did just now. A square is 0 1 2 4 mod 7. This is the topic of quadratic residues, which will come later in a separate section also. But it's common sense कि when you have A with some residue classes, when you square it modulo something, then only some numbers will be allowed. Not all of them will be allowed. So we will see similar problems. The next class will mostly be more problems. 1 or 2 classes we'll take to do some questions, and then after that we'll look at divisibility criteria using congruences, and after that we'll look at GCD and Bizot's lemma. So the course will progress like this. There will be some theory, then some problems, and so on. So attend the classes if you want to understand it. Don't miss out on any sessions. And if you have missed out on anything, then watch the videos.
Yes, sir.
Okay, fine. That's all for now. We'll
Thank you.
continue in the next class.
Thank you, sir.
Okay, thank you.